Pick up your phone. It works because of a battery. Leave a bicycle outside for a few months and it starts to rust. One process gives you power. The other slowly destroys metal. Both are controlled by the same idea, electrochemistry. Let's go a little deeper. Electrochemistry is all about electron transfer. When electrons move from one substance to another, a redox reaction occurs. One substance loses electrons, that's oxidation. Another substance gains electrons, that's reduction. They always happen together. No oxidation without reduction. But wait, here's the twist. If you control where electrons move, you can turn chemical energy into electrical energy. That's exactly what happens in a galvanic cell, the heart of a battery. Electrons flow through a wire from one material to another, creating an electric current you can use. Now here's something even more interesting. You can also reverse the process. In electrolysis, electricity is used to force a chemical reaction that wouldn't normally happen. Electric current pushes electrons in a specific direction, breaking compounds apart. That's how metals are extracted. That's how water can be split into hydrogen and oxygen. That's how industries shape raw materials. Let's connect this to real life. Batteries power devices. Corrosion weakens bridges and ships. Electrolysis purifies metals and produces chemicals. All of these depend on controlling electron flow. Before we wrap up, zoom out for a moment. Electrochemistry shows that electricity isn't mysterious. It's just electrons on the move, guided by chemistry. And that leads to the next question. If electrons move and reactions involve charge, how do we keep track of which atoms lose or gain electrons in complex reactions? That's exactly where we go next.